Commercial solar system design. You've got rail. So the question is, are you going to run it parallel to the rib or perpendicular? Let's find out. Valley from Greenwood here. We're talking commercial roofs, we're talking a ribbed situation, and we're talking solar rail. Do we run it parallel to the rib or perpendicular? Pros and cons. That's what you're going to learn in this week's video. Let's get stuck into it. And if you like what you see, hit that subscription button. Ready, steady, go. Let's go. Now, with large roof-mounted commercial solar systems, in many cases, the frame is laid FTR, flat to the roof, and this is perpendicular to the actual ribs of the roofing material used. Now, the distance between the ribs is constant and dictates where the actual rail feet are located. Now, there is another approach, and that's to run the rail parallel to the rib, and the positioning is only determined by the engineering report in regards to the foot spacing. In this presentation, we're going to ask this question: which approach uses more materials? I've selected Stramit Speed Deck Ultra as the roof example, and it has the following characteristics. You got center to center at 233.3 millimeters, 43 mil high, and it allows non-penetrative roof clamps to be utilized. And just check out the pic. We're talking about a 500 kilowatt system, and the solar barely makes a dent on the available area. Now, the component list is this. You got 5 100 kilowatt inverters, each of them with 6 maximum power point trackers, 2 inputs per tracker. There's 60 strings, 23 panels per string. Panel has a low VOC, 400 watt panels, and there's 1,380 of them. Let's get stuck into it. Now, in this example, I've used a near map image of the roof and got the correct dimensions and imported it into AutoCAD. And you can see that in the picture below. Now, have drawn the outer perimeter, and then I've used a gradient fill to show where the system goes. Now we can show the overall layout of the feet and framing with specific differences outlined if there are any. In this case, the section on the left is different from the right. And this is a common scenario when you're looking at these large commercial solar systems. It's not all perfectly symmetrical with plenty of unlimited room. Now, the section to the right consists of 23 panels in a row, and the section below consists of 11 and 12 panels in a row. So you can see that in the picture. Running rail perpendicular to the rib. Now, we're talking the following configuration. You got 60 strings as mentioned in total. 23 panels per string, 48 rows of 23 panels, and 12 rows of 12 panels connected to 12 rows of 11 panels. We're using 4,000 mil rail, and we've got a feet spacing maximum of 1,000 mil, and you've got a max panel cantilever of 500 mil, and the panel dimensions are nice and easy, 2,000 by 1,000 mil. Now, the engineer has said a max feet spacing of 1,000 mil, but the distance between the sheet ribs is 233.3 mil. So this defines where the feet actually go. Now, for example, let's look at the 11 by panel run. We'd usually require 12 feet per rail, so obviously 24 feet in total, but using a perpendicular approach results in 1+ foot extra per rail. So 2 extra overall, a total of 26. So running rail perpendicular to the ribs results in the following rail and accessory figures. 4,000 mil rail, 744 of them. Rail joiners, 600. Mid and end clamps, 2,856. Feet, 3,288 and $42,720 final figure. And have a look at the table below. Now, the engineer has set a max feet spacing of 1,000 mil, and with the frame running parallel to the rib, we don't have to worry about the feet at all in regards to their placement, but we do have to consider the rows side by side, expansion of the thermal expansion of the aluminium. And because of the configuration of the roof, we have the following rows. We've got 40 rows by 23 panels each, 40 strings. Then you've got 20 rows by 12 panels each, and that's part of 20 strings. And then we've got 20 rows by 11 panels each, which is again part of that 20 string. And you can see this in the pic below. So running rail parallel to the ribs results in the following rail and accessory figures. Here we go. 4,000 mil rail by 760 lengths, 600 rail joiners, end clamps and mids 2,888, 2,920 feet, and a total of $42,272. And you can see that in the table below. Now we can make a comparison here. In this case, the parallel to rib method is only slightly better than the perpendicular method for the same array, and the difference between being only $448 for the rail, feet joiners, and mid clamps. If we change the configuration slightly and reduce the number of individual 11 and 12 panel runs, this could help. We now have 44 rows of 23 panels each, so 40 strings. We have 16 rows of 12 panels each, and we have 16 rows of 11 panels each, and that's part of 20 strings. So we've got a total of 76 rows. So how the figures look now. So running a rail parallel to the rib results in the following rail and accessory figures. The rail, 736 lengths. Joiners, 584. Mid and end clamps, 2,872. Feet, 2,912. Total of $41,504. And you can see that in the table below. So spend your time having a look at that. As mentioned, we have to compare all the associated material and install costs for the three options under consideration. Parallel 1, cost per kilowatt installed at 41 cents a watt, and total cost. Total cost of $331,842 and price per kilowatt installed, 601.16. Perpendicular 1, cost per kilowatt installed at 41 cents a watt, total cost. Total cost of $331,398 and price per kilowatt installed, $600.36. Parallel 2, cost per kilowatt installed at 41 cents a watt and total cost. So we've got a total cost now of $331.901 and the price per kilowatt installed is $599. Conclusion. When assessing the viability of a particular design, the designer must, I said it twice, designer must take into account the material install cost ratio of the various components involved, as well as labour fatigue, time spent on site, the amount of packaging rubbish, roof mount versus ground mount, and more. Running rail parallel to the rib requires less thought, or does it, in regards to rail feet placement, as there is no incremental step as compared to a perpendicular approach. With any project costing, all this has to be taken into consideration. Good luck on your next project. Thanks for watching our presentation. I'm Valley from Greenwood. Hopefully you learned a lot about designing rail systems perpendicular or parallel. Now, if you like what you saw and you want us to make more of these videos, hit that subscription button. And if you've got any questions, inquiries, answers, or anything else, feel free to drop us a line, and see you next time.